Assalamualaikum class, how are you today? Okay, I hope you are in fine and we can continue our study today. Okay, like I say, okay, like I have told to you in last week that now today we will learn about work and energy. Remember? Okay. Now I will show you that what we will study in this material. Okay. Look at here. I have make mind mapping that we will study today. Okay. What is our subject? Our objective is work, energy, force, and movement. Okay, and then from them we can look for the relation from work, energy, force, and movement. Okay, ready? Okay, now before we step to our learning, I want to ask to you first, of course. Okay, now who knows what is work? What is work? Okay, now I will tell you in two definitions. Okay, what is work? This is work. Definition of work. Okay, look at here. The first is in KBBI. Di know KBBI Kamus Besar Bahasa Indonesia. In KBBI, work is an activity by mobilizing power, mind, and body to reach the goal. Okay, that's definition in KBBI. For example, I have. For example, look at here. This is the eraser. Okay, I want to move it from here to there. Okay. What must I do? What must I do to move it from here to there? Of course, I must push it. In that in that activity that I call that I have work done by me. Okay, I just to give a force, little force. And then, so I can move the eraser from here to there. Okay, then the activity I do is the name of work. Okay, understand? This is in KBBI. What is the definition in physics? Physics science. Oh, look at here. There is the definition of physics. No more difference. But you just to listen. Physics. The definition of work in physics is the force. You know that. Just now I give the force for the eraser. Okay. The force that force I give to the eraser is act to the object that effect. The force effect the movement of an object. Okay, or in other words, we can say that the work is be done by the object, by the force. Okay, so we know in physics that there is the object can move by itself without force and without work. Okay, understand? Yes. Okay, you have understand about the definition. I have a little question for you. Begin to look. Okay, begin to look. What are you looking? Oh yeah, some people push the car. Okay, some people push the car. So, what is the question, sir? This is the question. When we push the car, but the car does not move, do we do the work? Okay, alright. Like the definition before here, look at here, okay? The force that acts the object effects the movement. If there is no movement, we can call it we have work. Okay? Okay. Here again. And then what is the answer of this picture? When we push the car but it does not move, do we do the work? No. Why? Because the car is not moving. Okay? Good. Next, work. Okay. And then we have now the definition of work in KBBI and in physics. Now we can look it in mathematical. Okay, mathematically. Look at here. In mathematically, we can write that work is the multiplication between force and movement. Okay, alright? Or displacement in some factor. So, what is the multiplication, not the sum? Okay, look at here. In mathematics, we can write the work like this. Okay, okay. I will write it for you. Sorry, look at here. Work is W, okay, and then force is F. So the displacement is X. This is the multiplication. Why? We will have to multiply the equation. Okay, like I said just now, if the work or the force done to the object, but there is no movement, we do not work. If the movement is zero, what is the result of multiplication with zero? Alright, the work is zero also. And then we can multiply for the result in mathematics of work. Okay? Okay. This is the knot. You have to remember the knot. W is work. F is work. Sorry. Okay. And then S is displacement. Alright? Any question until here? There is no. Next. Now, you have studied about a unit. Okay? Magnitude and unit. In grade 10 maybe. In first semester, you have study about the unit. Now, what is the unit of work? Okay. Here is the unit of work that used in international. Okay. In system SE, CGS, BE. Okay. Here, okay. Look at here. In international, or we can say in system international SE, the unit of work is joule. Or in another unit, we can use energy. Okay. 1 joule. Okay. Where is the 1 calorie? Or we can use the calorie. 1 calorie is 4.2 joule. Okay. What is in another unit? What is in another another unit if we don't use the joule. Okay, you can do derive it in this equation. Understand? Okay, what is the unit of force? Good, Newton. What is the unit of displacement? Good, meter. And then the unit of work is F multiplied with S and then Newton meter. Sorry, Newton meter. Good. You are the best. Good. Okay, next. Now we have the unit of work, and then look at here. I will give you some cases related to work that the force do. What is the force? The force is when we push the object. We push the object. Look at here. We push the object. And then the object is moved from the first position. Then we call that we have to do work. Okay, look at here. In with note that the floor is slippery. There is no friction. Okay. Now, the force that acts to replacement in some vector, then the work is positive. Okay? What is the meaning? The meaning is, if the force vector in right, okay, the force that do the work, do to the object, go to rightward or to the right vector. So the displacement also to the right vector, and then we can call inside vector, then the work is positive. Okay. Okay, here what is the equation? This is okay. Look at here. I want to give you some cases that related work that the force do. Okay. The first is when we push. Okay, the object move from the first place or have the displacement, and then we can say that we have to work. This is the illustration. The floor is slippery, no friction, so we can say the force that acts with the replacement in some vector, then the work is positive. Okay, some vector is what's the vector of F? Good, to rightward. Okay, so the displacement also to the rightward. This is the equation. What is cos? Because this is the trigonometry. Maybe you will study it in math. Okay. This is the case same with the first picture in the first slide. Okay, look at it. There's some girl. This is girl or man? Oh, no, I think this is a girl. Okay, because she has a long hair. Okay, the girl is trying to push the wall, but the wall doesn't move. Okay, force that doesn't affect the placement of an object, then work is equal to 0 or null. Okay, is equal to 0. This is the mathematics, the mathematically. Okay, there is no displacement, and then the displacement is 0. So the result of work is 0 also. Understand? Okay, if you understand, now I will give you some sample. Sample problem. And remember, the sample is easier than the problem, right? What is the sample, sir? This is the sample. An object with mass 100 kilograms is on the frictionless floor, okay, and then the floor is slippery. It's pulled by a tow truck with the force F equal to 2,500 Newton. Then it moves 4 meters. What is the work done by the force? What is the work done by the force? Okay, because this is the sample, we can to solve it together. Look at here. Sorry. Okay, we can solve together. Look at here. We will see first what is the wall. It is the question. Alright? So what is the force? The force that effect. Okay. Force 2,500 meters. So the object is moved until 4 meters. We can solve it. It's easy. Work is F multiplied by S, and then 2,500 multiplied by 4. What is the result? Good, 10,000. What the unit? Newton meters. Or we can write it in 10 kilonewton meters, or another unit, 10 kilojoule. Understand over here? Good. Okay. Like I have said to you from the first minute, if you have understand that it's time to question. And look at here. What is the question? This is the question. Which is the biggest work done by the objects below if each object is given force 10 Newton and slide rightward 4 meters? The floor is slippery. What's the object? Wait, this is the object. A, B, and C. What's the biggest work done by the force? The force is same. This is 10 Newton, 10 Newton, and then 10 Newton. But you can solve this problem just to look at the picture. So you can find the answer. Are you sure? Really? Why? Because look at here. Here is the angle of 0. Oh man, what is the cos 0 degree? Good, 1. This is the angle of perpendicular or 90 degree. What is cos 90 degree? 90 degree is 0. Right? So if this force multiplied by 0, what is the result? Good, 0. If force this multiplied by the displacement, what is the result? Good, 40 Newton. So this is how the cos of 45 degrees. Cos 45 degrees, okay, right here. Cos 45 degrees is equal to half root 2. Okay? And then if we multiply the force, then multiplied by 4 is 40. So multiplied by half root 2, and then the result is 20 root 2. What is the biggest? Okay, good. Of course, the picture of A. You are good. Again, any question? If there is no question. For more your understanding, I want to show you this is what is this? Okay, here. For your more understanding, please look out this video. This is the video. Okay, watch out. Look at carefully. Okay, guys. This is a video about work. So maybe some since there is about energy also, but in energy section maybe I will explain you in next minute. Okay, in next minute I will explain you about energy. So I will explain you about relation between work and energy, so we can find work from energy, or also we can find energy from the work, because energy and work is just in a circle that we can say, oh, it is conservative or immortal. Okay, okay, here this is because the video that's here. Okay, this still what is the opening scenes. Okay, get ready. This is the video. Let's just do the meteor. Okay, down to the planet, and then boom, Big Bang. Big Bang also is from work. Okay, later we can solve it. What do you see? Good. You see an athlete is to pull the barbell to pull up the barbell from floor to his body. Atlet melakukan usaha ketika ia menaikkan barbell dari lantai ke atas kepalanya. Tapi tidak melakukan usaha ketika menaikkan barbell saja dari kepalanya. If he hold barbell here, he doesn't do the work. Okay? What is this? Roller coaster. Also, roller coaster is used the concept of work and energy. Okay? Any question? Okay, maybe if you still look at this video, I just to say if there is another question, I think I finished until here because maybe you hear the bell. Bell is ringing. Okay, bell was ringing. So and then maybe enough here what I can explain to you. So the next objective is about energy and the relation between work and energy. Okay? Then if you want to more understand, you have to read it first in your room, in your home. Okay? Okay, maybe enough here and the last. Say you goodbye, see you later in the next meeting. Assalamualaikum warahmatullahi wabarakatuh.